2D SUVAT. So before, we did variable acceleration, where A was not constant, which is why we had to do integration, differentiation, all that good stuff. But now, we're going to look at constant velocity, which means A is fixed, which means we can use SUVAT in 2D, okay? Now, when it comes to SUVAT, we have all of our formulas. Now, I'll recap it really quickly. We have V equals U plus AT. We have S is U plus V over 2T. We have S is UT. S is UT plus half AT squared. We have the basic VT minus half AT squared. V squared is U squared plus 2AS. And I think that's it, right? Hopefully I haven't missed any. But if I have, the game's the game. Now, which one of these can be represented in vector form? Only 4 of them can. The only one that we cannot is this. The reason for that is if I underline this, representing velocity, initial velocity, acceleration, and displacement as a vector, what does v squared mean? What does it mean to square a vector? We don't know. What does this mean? It doesn't mean square the 1 and square the 2, that's for sure. In maths, we have so many different things that in different fields it could represent. So we have cross product, we have dot product, all of that good stuff. This, not allowed. This we can do this because t is a constant, yes, a scalar value. You can do a scalar times a vector. You can underline that because you have a scalar times a vector, that's all good. For the same reason, this is allowed. This one's allowed because you're taking 2 vectors, adding them together, halving the numbers and multiplying it by t, that's okay. And here as well, that is alright. All you're doing is taking a vector, multiplying it by a constant. So those are the only vectors that we are allowed, where's my rubber? We are allowed to underline and use in vectors. So there's only one that we cannot. Right. Let's address this question. It says 2 boats, A and B, are moving at constant velocities in the ocean. At noon, A is at the point with position vector 2y minus j kilometers, all relative to the origin, obviously, if we're using I and j. And half an hour later, it is at this position. At noon, B is at the point with position vector this, and 90 minutes later, it's at this point. Find the closest distance between A and B and the time this occurs correct to the nearest minute. Right, with all these kind of questions, guys, 8 marks, I recommend you do a sketch. Okay, let's figure out what's even going on here. So we have our x-axis and our y-axis. So A is initially at this point 2 minus 1. So 1, 2, minus 1. So that's when t is 0. Then half an hour later, we like to generally talk about hours for this kind of stuff. We're talking about the boats. It doesn't actually make a difference, but I'm going to say t is 0.5 rather than 30. So half an hour later, it's at minus 1, 5. So minus 1, 1, 2, 3, 4, 5. Obviously, it doesn't need to be an accurate image. This is just for us to kind of get an idea of what's going on. So that's the journey of boat A. Boat B is at the point with position minus 1, minus 1, which is down here. So that's t is 0 for boat B. And then 90 minutes later, so an hour and a half later, it's at 5, 5. So 1, 2, 3, 4, 5, and then up here. Okay, that is a terrible cross. But there you go. T is what, 1.5 for 90 minutes? The question is saying, find the closest distance between A and B and the time this occurs to the nearest minute. And the closest distance, I've just made it up. We can figure out our accuracy. That's not really the main point of the question. Now, a lot of students would draw this and say, isn't it 0? No, because they're traveling at different speeds. So they don't intercept each other. They don't crash into each other. One might be going super fast and one super slow, and we're trying to find out when are they closest together. So for this, we're going to have to work out their displacement, their general displacement. How do we calculate the general displacement in SUVAT terms? Well, we have their initial positions and we have their velocities over time. We can work that out, okay? So how do we do that? you know when we said v equals u plus at? There's actually a new formula we need to be familiar with. What is that? What does this statement even say? It says your final velocity, or your velocity in general, is determined by your initial velocity and your acceleration over time. So your velocity depends on your initial velocity and your acceleration over time. Here, in our case, our displacement, our position, depends on where we started and our velocity over time, because your velocity determines your direction of motion. Okay. Now we can do that for both ships. Okay. So we can work out their velocities based on this. So for ship A, its end position was -1,5. It started at 2 minus 1. And when t is 0.5, the velocity was whatever it was. So we can work out what the velocity is here. So we're going to minus, so we get -3, then 6 is 0.5 v. So then we're just going to times by 2. So we get -6 and 12. So the general position then of A is where it started, which is 2 minus 1, plus the velocity, which is this, over time. Now for this kind of stuff, guys, we like to combine them. So 2 minus 6t and -1 plus 12t. And now we need to do the same thing for B. Hopefully the numbers are not too horrible, because I literally just made them up as I was writing it. So anyway, it ended up at 5,5. Is its initial position at -1, -1. And it took an hour and a half, right? Oh, I think it does, because when you add that over, you get 6,6. This was not intentional. But it does work out beautifully, because that is 4, right? So we get 4,4 for your V. That's written so badly, but you know what I mean, innit? Right, so now that we have this, I can write, I'll keep that image for you guys. Don't need this. Let's write them out nicely. So we have RA is 2 minus 6t and -1 plus 12t. And RB is, so RB is the initial position -1 plus 4t. And then -1 plus another 4t. Okay, nice. Now, the question's saying, what's the shortest distance between these two ships? Well, how do you work out the distance between two objects? Well, remember, these are basically just coordinates, right? So you subtract them, then Pythagoras. So the distance between them, we're going to subtract them. It doesn't matter in which order you subtract them. But now we have to be very careful how we do this. So we're going to do 2 subtract -1. So you can obviously write like this, but make sure you use a bracket. We have -1 plus 12t minus -1 plus 4t. But what do we get? 2 minus -1 is 3, minus 6t minus 4t. -6 minus 4 minus 10t. -1 minus -1, they cancel, which is great, non-intentional by the way. 12t minus 4t is 8t. Now to do cheeky Pythag is going to be the root of 3 minus 10t squared plus 8t squared. If we call that d, I actually don't like working with the root, but we'll write it like that for now. Okay, so we get a root of 3 squared is 9. Multiply these together is minus 30t. Double it, minus 60t plus 100t plus 64t squared. I actually like working with d squared because of what we're going to do next. Well, I was going to reach for my calculator. Do I need to calculate here and have 164? No. Wait, this 100t squared, isn't it? That's why. 164t squared. Now I'm bugging. Minus 60t. Then plus 9. Now we want to minimize this. Okay, so quadratic. How do we minimize this? We just differentiate, make it equal to 0. Yeah, you could complete the square, but that's just long. Now you might be wondering, wait, but that's d squared. D is obviously positive. So where d squared is smallest, d is also smallest. So that's why we're not working with the root. So we're going to differentiate this. So d by dt. I'm not going to write d by d squared. It just looks weird. So you have what? 1, no. What is that? 328 or something. I don't trust myself. 164 times 2, 328. T minus 60 is 0. T is 60 over 328, which is 15 over 82. I mean, I did not expect this to be nice numbers. Okay, so that's 0.1829, 0.1829 after noon, and this is in hours, okay? So we're going to have to find the time for that later on. Now with that, we can then find d minimum, okay? So d min is going to be the root of subbing that into all of this. I'm not going to write that down. But I'm going to store this value, store it. I'm going to do 164 a squared minus 60 a plus 9. Oh, I actually get a nice number. 144 over 41. It's crazy how maths works. But then I have to root it though. Does it give me a nice number? Huh. 12 root 41 over 41. I'll keep it like that. Kilometers. That works out to be like 1.87 kilometers away from each other. But now let's find the time. Now, on the calculator, so when I do alpha A, I get that 15 over 82. On the calculator, for me, above the ENG is like this circle, comma, double comma. If you press that, it actually converts it to the time in minutes and seconds. So this is saying 0 hours, 10 mins, 58 seconds, and 54 milliseconds. So to the nearest minute, that's actually 11 minutes. Okay, so that's 11 minutes after noon. So the time would be 12:11 p.m. All right, and those are our two solutions. No, you guys could write that in however way you want. But that's it, okay? So I wouldn't say it was the hardest question, but it's a very important question for 8 marks, yeah? Students always neglect this kind of mechanics. They just focus on the resolving and, you know, the moments and all that stuff, and they neglect all of this stuff. So hopefully this is a good reminder for you. This actually concludes my mechanics series. I move on to statistics now. But yeah, guys, if you did learn something here and amongst all my other videos for mechanics, I'd appreciate if you hit the like button, subscribe for more maths content, and if you're interested in my A-level maths courses, feel free to check the link in the description, and feel free to join the Lung Gang Reddit if you want to submit your own questions for the community to get feedback. I'll see you guys in the next video. Nice.